Ha! Pythagorean Theorem, one of the most famous algebraic formulas ever. This is a really handy thing to memorize. It's used quite a lot, and it's actually not too hard. So here's our example. It says for the following right triangle, find the side length x and round to the nearest tenth. Okay, it's important to note these are for right triangles. Okay, what we need to understand is this. This is the important formula that I highly recommend you put in your notebook and can commit to memory. So in the Pythagorean theorem, if we have the legs, let me grab this. The legs are A and B, and the hypotenuse is C. Remember, the hypotenuse is the word we use for the leg that's always across from the right angle. Always and always, this is the hypotenuse. If we look at another example of a triangle, let me draw one over here. If we draw a right triangle like this, here's the hypotenuse. Oops. Because it's across from the right angle. That's always and forever. So that will always be represented by C in this equation. The other two are always going to be legs, and it doesn't matter which is which. This can be A or B, or you can say this could be B, this could be A. It doesn't matter because they're both legs and they just go on this side of the equation. So here's the graphic. Okay, A squared plus B squared equals C squared. Now if we take a look at this drawing and we compare it to our original, we can transfer over the information. This 12 is in the A position, right? So that means A is 12. This 8 is in the B position, so that means B is 8. And then of course C, that's X. That's where this came from. So when we plug that into our equation of A squared plus B squared equals C squared, this is what we get. 12 squared plus 8 squared equals X squared. Now we get to figure out how to solve that. Alright, so we want to solve for X, and here's what we've got. We've got 12 squared plus 8 squared equals X squared. We know that 12 squared is 144, 8 squared is 64, X squared stays the same. We can add these two together to get 208. Now this is important because this is a little bit confusing. The ALEKS explain doesn't really show this next step. If I can rewrite this as X squared equals 208, it's the same thing. Now in order to change that X squared into an X, what do we have to do? We have to take the square root of X, because the square root of X squared is X. If we take the square root of one side, we have to take the square root of the other side. That's where this comes from, because by definition the square root undoes a square. So right here, taking the square root of X squared gives us just X. And then using our calculator to take the square root of 208, we get this number and we round it for our final answer, 14.4. Okay, one more example. Let's take a look. Here we've got another right triangle. Remember, our A and B are legs. C is the hypotenuse. So we have to identify what's what. The hypotenuse is always across from the right angle. So that means this is going to be our C. What's the formula we memorized? a squared plus b squared equals c squared. So we know what c is. We can take a look here, and of course this can be a or b, doesn't matter. So let's plug them in. What do we get? A squared, that's 20 squared. B squared, that's going to be x squared. And c squared is 25 squared. Multiplying out, we get 400 plus x squared equals 625. Solving this for x, we have a couple of steps. First thing we have to do is we have to subtract 400 from both sides. If we subtract this 400 over here from this side, we have to subtract 400 from this side because we want this to go away. So we're just left with our x squared. So we end up with x squared equals 625 minus 400 is 225. So here's a tricky part that ALEKS doesn't explain very well. We have to take the square root of x squared to get x. Anytime we do something to one side of an equal sign, we have to do that same thing to the other side of an equal sign. So what we get is the square root of x squared, which is, let's go over here, x equals the square root of 225, which is 15. There's our final answer.